Good afternoon, it's Jeremy. It's Wednesday, April the 23rd, and this is a remake of a video I did a few days ago. I decided that there was just too much to cover in one video, so I'm going to do it in 3 or 4 different videos. So basically what I'm looking at here is I'm looking at a 433 megahertz 70 centimeter receiving setup for amateur satellites or CubeSats. Now previously I received NOAA satellites, and I've received GOES, and I received the hydrogen line. And when I did that, I usually had a module like this, which is a low noise amplifier and a bandpass filter. I couldn't find one for the 70 centimeter band, so what I did is I purchased a bandpass filter separately off Amazon. I got a 433 megahertz amplifier as well, so I put them together. So that's kind of the equivalent of this guy. And since it doesn't have the bias T, I've got a lithium battery pack here, which I got from the Toronto Film Festival. It was a handout, and it produces 5 volts. It's a cell phone charger, and I use that to power the 433 megahertz amplifier. Now, it's just a V dipole. You'd be much better off with some form of Yagi, but this is an apartment building, and people are very sensitive here. The minute something weird appears in the balcony, you get in trouble. So this thing I can remove inside reasonably easy, and I can move it in different directions. So that's the RF setup. Let's go and look inside at the setup, receive setup software. I'm looking at here is SDR Sharp. So basically SDR Sharp is my go-to program just to see what's going on. And we're going to see in later videos, to decode the signal, we're going to need a GNU radio, and I'll be using the out of block module from Daniel Estevez, who's a ham operator, and he's created a whole library of decoders for satellites, so we'll be using that. So I'm going to switch over to Camtasia. So what we're looking at here is we're looking at SDR Sharp. So the past couple of evenings I've been trying to receive EIRSat-1, which downlinks at 437.1 megahertz with a GMSK type of signal. I did get some promising looking pulses, but they didn't coincide with the particular path as a satellite, so I don't think it was that particular one. However, I'm going to show you in a minute. Basically, I'll play back the IQ files. This is the setup I used. I set this up at USB, so there's 437.1 in the middle, so there's 20 kilohertz of bandwidth, and I saved the samples in IQ format and in WAV file as well to look at. So that's what I did the past couple of nights. And like I said, I thought I had a satellite, and it wasn't. It was something else. It looked like the same type of signal. So we'll investigate that further. Now, another thing you can do, let's just stop this for now. Another thing you can do, and what you'll be doing for the decode, is you can use GNU radio. So basically there's the RTL source module, and it'll be connected to the RTL-SDR. Incidentally, all the details are in the blog post for this. So I've set the frequency up at 437.1. I've got a low sampling rate of 200K. We don't want to have the whole bandwidth. We know what frequency we're on, so 20 kilohertz of bandwidth, that's fine. And there's a GUI sync. Right now I've got the file sync grayed out. So basically what you could do is when the satellite passes over, you could save this to a file, and you could play it back into the decoder, which we'll look at later on. So let's look at a playback of what I received the other evening. Okay, so this gives you an idea of what we can receive. Like I said, I received this the other evening. I don't know what satellite it was, but let's just play this and we'll look at it. There you see, this is a GMSK type of pulse. It's round, it looks like an inverted bowl. It doesn't have the sine x over x shape of, let's say, QPSK or something like that. That's what GMSK looks like. So that's what I received the other evening. And I saved it as an IQ file. This is a GMSK modulator on GNU radio, so we can see with the same shape. So I'm going to, this is from the GNU radio org site. I got that file. So let's just run this and see what it looks like. So you can see this is the shape of the output spectrum, which is exactly what I received there in 437.1 megahertz. So in the next couple of videos, what we'll look at is we'll look at tracking, and we'll also look at how to decode these particular CubeSats. And like I said, I'll be using the GR satellites out of branch modules from Daniel Estevez, who's an amateur radio operator. I think his call is EA4 TMC, something like that. So till the next video.